Welcome to the Arweave DataFi workshop. In this workshop, we are going to cover atomic NFTs. So, DataFi is this concept of combining permanent data storage, NFTs, Permaweb, SmartWeave contracts, and profit sharing tokens in ways to bundle together to satisfy many different use cases with permanent data, from making it dynamic with attention tracking, to being able to programmatically change attributes of data on the permanent um, Arweave network. So in this workshop, we are going to talk about atomic NFTs. To get the most out of this, you should be familiar with the concept of blockchains, the concept of NFTs, and have some good skills around being a full stack developer, primarily HTML, CSS, and JavaScript. Also, Arweave concepts, understanding the data storage and SmartWeave concepts. If you don't understand those, check out arweave.org, or, check out the previous workshop where we talked about the Permaweb and combining the Permaweb and SmartWeave. The tools we'll use in this workshop is a code editor, Node.js version 16, and AR Local, which is a DevNet. And basically, we'll be able to use this instead of having to have AR to write smart contracts on the mainnet. So we'll be able to use our local as our DevNet. Just to recap the capabilities of DataFi, I think it'll be best to unpack each capability and describe how they work in a basic level. So, in the last workshop, we kind of broke down a Permaweb app and a SmartWeave contract. And in this workshop, we'll break down atomic NFTs. So, on Arweave, we have a trustless, permissionless, and composable platform where we can deploy data and we can deploy applications. And we have these tools like the Permaweb and SmartWeave contracts and atomic NFTs and PSTs. And I'm kind of composing those together into this DataFi concept. So, what is an NFT? Um, you know, the basic kind of definition is it's a token that shows ownership of an asset. In most situations, a digital asset. And that digital asset can be many things. And part of the Atomic workshop is it can also be application or be HTML. So you can have HTML, CSS, and JavaScript part of that stored on the permaweb. So it's immutable and it cannot change, and it can be wrapped with a SmartWeave contract. In this workshop, we'll just take a SVG file and wrap it to demonstrate the same process. And our goal today is kind of to break down kind of the raw bits of an atomic NFT. So NFT shows ownership to a digital asset. An atomic NFT is where media assets and the contract metadata are stored together immutably under a single unique identifier. So I like to kind of visualize this as this box is your Arweave transaction, your identifier, and then you have your data or your digital asset, and then you have your SmartWeave contract, the actual code, the initial state, and then your metadata that really lets these tools know what it is that you have. So you have metadata there in the form of tags in an Arweave transaction. And there has been kind of several kind of evolutions of atomic NFTs. And currently, this iteration is based on AtomicNFT.com. And, if you want to go check that out, it's HTTPS AtomicNFT.com. Pop that on there. And that can give you a description of the standards and gives you a little bit more details of this. Now, the system, the ecosystem and the community are evolving. So, these things may change over time, but that can, kind of give you some guidance here. And I'm going to try to go through kind of um, the specifications, current specifications of this. And this site was published by the Koi Network, and there's other folks that have other takes on NFTs in the Arweave ecosystem that are in the process of publishing their standards and specifications as well. So the initial attributes, you have an initial state in a SmartWeave contract. And here's kind of the initial attributes of an atomic NFT based on the AtomicNFT.com site. You have an owner, which is the address of the creator of the NFT. Now that will never change, even if the ownership is transferred. So it's the creator, and then the title is the name of the NFT. Description is a description of it, and then you have these name ticker attributes which can associate to a PST. And two examples: one could be a Verto PST, another could be a Koi PST, and we'll explore others in later workshops. And then you have this balances object, and this basically keeps track of the the owners of the NFT. So you have address as a property and quantity as a value. And with NFTs, since they're non-fungible, there's kind of one owner at a given time. The locked array, this is for a extended feature of this atomic NFT to bridge other L1s like Ethereum or Solana, etc. We won't talk too much about that. I don't know, um, how that's going to evolve, but definitely not part of this workshop. It's just a requirement to this NFT standard. Then we have the content type, which will be the type of digital asset. In our case, it'll be an SVG for this workshop. Then we have created at, which is a Unix timestamp. Um, then tags is an array of strings that basically allows marketplaces to organize your NFT with others. Maybe a collection, for example, if you have an NFT collection, etc. So those are kind of the core initial state attributes. And then we have metadata tags, and these go on as tags to the transaction. And since this is a SmartWeave contract, you're going to have app name, app version, content type. Any kind of data on Arweave should always have a content type. And then you have this action, which marketplace slash create is kind of defines the atomic NFT. And then a network is, kind of unique to Koi if you're planning to use Koi for attention tracking. And then contract source, part of a SmartWeave contract, it has to point to some source code. And then initial state is all of the state attributes stringified in a JSON object. The other aspects of an atomic NFT is their methods. You have two methods in the core. balance, which is a read method, and it returns the balance of a given wallet address. And then you have the transfer method, which is a write method, which allows the owner of the NFT to transfer their balance to another wallet address. And we'll demonstrate how that works in the workshop. And Atomic NFTs extend two other concepts: the dynamic concept, where you're wrapping your digital asset is really an application, and you're wrapping that around the Atomic NFT standard, and then bridging, and that's the ability to delegate ownership to another chain. We probably won't go into that much, but the dynamic in future workshops will cover that. We'll actually create a dynamic web app, a Permaweb app, and mint it into an Atomic NFT, which would be pretty cool. But the basic Atomic NFT is what we're going to do today. And we're going to take our friend here, Winston, and we're going to make Winston an NFT. So with that, we're going to go ahead and jump into the workshop. And we're going to open our Visual Studio Code window right here. And we have just an empty repository. And I'm going to see if I can't get my notes up really quick. Okay. So the first thing we're going to do is we're going to use AR local so that we don't have to have AR in our wallets and go through that as part of the workshop. We can do everything with our development environment here. And AR local is a local application that simulates an Arweave gateway and an Arweave network. So we'll install that by doing npm install -g AR local. Okay, and once that's installed, we will run it. Shouldn't take but a minute here. So we'll run AR local on this terminal window, and we'll add a new terminal window where we'll do our work. So we'll have a new window here where we'll work in our project while we have AR local running in the background, and we can kind of go check out AR local here. We'll pop that up, and you can see that it's running under localhost port 1984. Now we're going to create a new directory called Atomic NFT Demo. And in that new directory, we're going to create a project. So I'm going to use Yarn. So Yarn init -y, and you can install Yarn by just doing npm install -g Yarn. It's pretty easy, or you can use npm with your stuff as well. So we've got a package JSON, and now what we want to do is essentially make the package JSON of type module. So we'll say this dot type equals module, so we can use ESM import statements in our code here. So we're just going to use this JSON tool to do that. And let's go ahead and pull down our NFT, our image. So we're going to use curl, and this will be in the show notes of the video, but we're going to just pull it down from, you guessed it, Arweave. Imagine that. And then we're going to just rename it by moving it to Winston.svg. So that looks better. And that's going to be our digital asset for this Atomic NFT. So we do have some dependencies before we start writing code. The first one is Arweave. So we want to npm install Arweave, and we're going to specify the version of 111.4 just to make sure we're using a version that works in case you're seeing this ahead of time or in the future of the recording, which everybody will be. This will make sure that you have consistency. Um, so we're using Arweave, and now what we want to do is create a wallet. Now, if you were going to do this on mainnet, you would have a wallet and you would have some AR in it, and you would use that wallet to essentially mint this NFT. We're going to use AR local, and so we need kind of a DevNet wallet to do that. So we're going to actually do that with code, which is a lot of fun, really. Um, I think that's pretty cool that we can you know, create wallets just with regular old JavaScript. It's kind of fun stuff. So we're going to import Arweave from Arweave and import file system from file system or FS. And I'm going to just copy all of this code over and talk through it just to save some time. But basically, we're going to init an Arweave connection. Then we're going to generate a JWK for our wallet. And then we're going to grab the address of that wallet and we're going to save it to wallet.json. And then finally, we're going to mint 100 AR to that wallet. And that's going to really help us, write our transactions to the DevNet. So we'll just run that, and hopefully we've got a wallet JSON and it's minted. So I'm going to mine our local DevNet. So we say curl localhost colon 1984 / mine. And that'll just process those transactions on the DevNet. So now that we've got our wallet, we've got our data, which is Winston.svg, and now we need a contract. We need a smart contract. So we could use one that's already out there, but since we're in a workshop, we're going to actually create one because I think it'll give you a really good idea of how all of this stuff works. So we're going to create our own smart contract code or source to use in this NFT. So we'll open that. And one of the things to keep in mind is that the contract should be pure functions. There's a lot of great new features coming with Redstone, and they're going to call it Warp instead of SmartWeave contracts, which is a pretty cool name. But you can do like internal rights, and you can use other languages and different different virtual machines. So that's going to be really cool to see how that kind of comes together. But for now, we're using JavaScript and kind of this reducer pattern. So the main method that a smart contract has is the handle function. So we'll say handle, state, and action. And then I've got a little boilerplate I put in here just to, kind of keep my functions kind of standalone so I can easily write unit tests with them. So this object is got my list of functions. And then when handle's called, it checks and sees if the input function is in that list. Then it calls it, returning the state or action. Otherwise, it returns a contract error. Now you can organize these however you want. This pattern works well for me. But again, whatever works. The end of the day, it's just a reducer pattern. and you have an accumulator and a value, which is state and action. And then you have to return either new state in an object or a result if it's a read-only function or an error, right? So those are what you have to return. So what we're going to do with the balance, let's go ahead and destructure some things and then make sure that everything's a string. So what we're going to do is destructure action into input and caller and make sure input target is set. If so, that's our target. If not, we'll use the caller and then we'll destructure our state into a ticker and balance, and we'll just make sure target is equal to string. And then since this is a read method, we're going to return a result. And that result is going to be the target, the ticker, and the balance. And we'll look up the balance by checking to make sure that target is in balances. And if it is, then we'll return balance target, which will return the quantity value of that particular wallet address or target. Otherwise, we return 0. So that's our balance function. Now, our next function is our transfer function. So we'll transfer ownership from one owner to another. And that's, state and action. And what we're going to do is go ahead and destructure the action and the input to get input and caller and target and quantity. So with the transfer, it's a write transaction, and we need target and quantity from our input in order to properly um, write the interaction and actually adjust the contract state. So we've got that, and we're going to add some asserts to make sure everything's valid. Then we're going to destructure balances, and we're going to make sure that the caller has enough quantity that they can actually do the transfer. If not, we want it to exit. And then we're going to implement our transfer. So here's our code to do that. Basically, we decrement the quantity from the balance of the caller, and then we increment the quantity to the balance of the target. And it's that simple. And now we just need to update our state and return state so that we get a new state in our contract. And that will essentially move the NFT from wallet one to wallet two. If wallet one's the caller, they have to be the owner, and they can move the quantity from themselves to a new wallet. And now that wallet becomes the owner of the NFT. Pretty cool. So now that we have our contract, we are ready to mint an NFT. And in order to mint the NFT, we're going to create a file called mint.js. Okay. And we will need Arweave again and FS. And I'll just paste those in. And we'll need to initialize Arweave to the local host. And now we'll need to bring in our wallet. And hang on. Okay. We'll need to bring in our wallet and our source code. That was what I was looking for. So um, let's go ahead and load those from the file system. So we'll load our wallet and our source code um, from the file system, and we'll go ahead and get the address of the wallet too, because we'll need that as well. And then we're gonna create our source code transaction on Arweave. So const c source equals await Arweave create transaction, and our data will be our source code, right? And then we have just a few tags that we need to add for a SmartWeave contract. So we have the content type, which is application JavaScript, the app name, which is SmartWeave contract source, and then the app version. And then once we have that, we can sign our contract with our wallet and post it to uh, Arweave, in this case, AR local. Now that we have that, let's go ahead and start to build our smart contract. So to build that, we need to get our data, which Winston is our data. And then we're going to create the contract, create the transaction, setting data to Winston. And now we need to add several tags. And I'll go ahead and just paste those in and talk through them. Content type is image SVG. The network COI, this is, kind of a requirement of the COI version. Then action, marketplace create. I think both Verto and COI network uses that. And then we have app name, SmartWeave contract, app version. Then the contract source is the contract source we just deployed. And then this is a new flag, not suitable for work. We'll say false. And then we need to set our initial state tag, which will contain the initial state of our SmartWeave contract. So in the previous workshop, you should have seen this before, but init state, and then we just basically take all the attributes of an NFT and apply them. The owner with the address, title, description, and then these two are kind of specific where we're mapping to a PST. Then the balances with the address, which is the owner, we give it a 1, and then content type created at tags, we'll leave that empty, and then is private false. So we've got all of those things in, and we've added all our tags. Now, all that's left is to sign and post the NFT, and that will complete our minting process, right? So we sign the contract and we post the contract to the Blockweave, and we can print out the contract ID. With that, let's do node mint.js, enter, and we got an error. Let's see. Ah, my wallet.json. That's not what we want. We want wallet.json. So just a typo. Cool. Now let's try that again. Sweet. And we will just curl and do localhost 1984 mint or mine just to mine that. But now we've got this contract ID, and it's also an NFT. So if we go to the URL here that we had in AR local and just do slash and paste our transaction ID, we get our NFT, which is pretty cool. And we can actually open up GraphQL and run a query for transaction. We'll paste our transaction ID down here. and just get the ID and the owner address and tags, name, value. We can take a look at our transaction. So our ID and our address, and we can see that it's a SmartWeave contract, and we've got our contract source, and we've got our state stored here as well. So pretty awesome. So it's a SmartWeave contract, and it is a NFT or the URL, the data asset of the NFT. And we can read that, right? So let's go ahead and create a new file called read contract. And let's work through what we need to do to read the balance. Let's call the balance of the contract. And what we need to do is install a dependency. We'll use Redstone SmartWeave. So we're going to do yarn add Redstone SmartWeave. We're going to use version 5.7. And we're going to set up this read content with some basic stuff. We want Arweave. We want Redstone SmartWeave. And we're going to use the SmartWeave node factory to basically call our balance method on our smart contract. So we're going to initialize that using Arweave gateway.build, so it will use our local host. Now, if you're using mainnet, basically you would use the Redstone gateway because it's much faster than the Arweave gateway. So it would be something like this to initialize that gateway on production or on mainnet. Now we're going to grab our contract, and our contract identifier is the identifier of the smart contract that we just ran, or our Atomic NFT. We'll grab it here. That's our contract. And we want to find the balance of the owner. So we can use GraphQL here. We printed out our owner address, so we can make that our target. So we'll do target equals that wallet address, and then we're going to make our read call to be await contract view state. We'll say function balance target will be the target that we just supplied, and then let's just log that out. So console.log result. So, and now we can run read contract, and we get undefined. So let's see, let's back up and see what we may have done wrong. Got the contract here, owner address, balances. Let's see, what did I do wrong? Balance. Maybe I had a bug in my contract here. Target in balance, balance target 0. Balances. Pull the balances. Let's look at our mint. Maybe Misspelled balances, possibly balances. Okay, so we'll figure that out. Let's see. Let's do read state, which will read the entire state. So let's comment that out and do console log, await, contract, read state. That should print the whole state out. We have our balances. Quantity one looks right. Oh, you know what? So we're running AR local, and what we have to do is mine those transactions. So I think I just needed to mine the transaction. So we'll do curl local host 1984 mine. And now if we run read contract, still get undefined. Um, hmm. Okay, I'll figure out what could be going on there. But we know we've got the balance of one, so obviously there must be some sort of bug in this um, call here. Result, balance, target, target, ah, balances. There we go. So let's quickly rewind our process here. So we're gonna do another mint. So we'll call node mint.js, and that'll give us a new contract. So we'll go to that contract in our read contract. And it should be the same target. Let's go ahead and curl and mine just to make sure. And then let's do read contract. Yes, we have balance one. Whew, just a typo. That's why it's important to test your contracts because you don't want to deploy that on the main net and it be wrong. So now let's go ahead and transfer an NFT from um, this wallet to another wallet. So in order to do that, what we'll do is we'll create a wallet two, and we'll just call, just to make it easy, create wallet 2.js, and we'll just make the change here, and let's console log the new wallet address. That, I'm going to say node create wallet 2.js. Right? Oh, what did I do? Well, ah, I just didn't put it in the right directory. Oops, hang on. Yeah. Okay. So we got create wallet 2, and that's our address. So what we want to do is transfer the NFT to this address, and we'll create a file called transfer owner.js. And in that file, we'll say const target equals this wallet. And we need to kind of import Arweave and Redstone SmartWeave. And we need to grab our wallet of the owner, which will be wallet.json -8 because it's a string, like that. So that'll be our wallet that is the owner of the NFT. And then we have our target. And then we're going to initialize Arweave and Warp or SmartWeave contract library. So we're going to initialize those two things. And then we're going to get our contract. So we'll say const contract equals warp dot contract. And we want to grab the contract that we just minted, which is, let's see, the easiest way to find. Let's go up here and we've got the, let's see, use GraphQL to look at transactions and edges and node and ID. And we want to look at owners. And it'll be an array. And our owner will be, well, let's just leave our input criteria blank. And we know it's the most recent one here. We can verify that. Let's open our local and go that up. Yep, we've got our NFT. Okay, so we've got our contract. We need to connect it to our wallet of the owner of the NFT. So we need to do that. And now we can initiate the transfer. So we'll call await contract write interaction. And we're going to pass in our function, which we want to call, which is transfer. And transfer requires a target, which we have above, and a quantity, which we want to be 1. And then we can say console log transferred NFT. Yay. So in production, I recommend using bundle interaction instead of write interaction because that'll go through the bundler and it seems to resolve faster. Let's go ahead and run our transfer and move it. Yay, we transferred the NFT. So if we run node read contract, let's see, make sure it's the right contract. Oh, okay. So we need to mine that. And now if we run read contract, yes, our current wallet is 0. If we look at the new wallet, so let's take read contract and create a new file called read contract 2. And let's look at our new wallet. So we're going to grab the new wallet owner. Let's see, we transferred owner. We'll grab it here. And if everything is working well, when we read the contract of the new wallet, it should be one, right? And it is. So we transferred the NFT from one wallet to another wallet. Pretty cool. Uh, so with that, that kind of concludes the workshop and shows how to create a smart contract, create a NFT inside that, using that smart contract, and then using the balance function to get the balance of an owner or wallet, and the transfer function to move it from one wallet to another wallet. Now, this is the very basic stuff, but I felt like it was important to work through this, work through it at the lowest level possible so you can get a full understanding. And as we start to compose these things, it will start to make more sense. So hopefully you enjoyed this workshop. And if you have any questions, feel free to hit me up on Discord, T Wilson 632 in the Arweave Discord, or on comments on YouTube. Thanks again. And the next workshop, we will be sort of showing atomic NFTs in practice using Koi, and showing how you can, kind of combine all these concepts together. Thanks.